Okay, we're getting started in a minute. I've gone ahead and started the recording. A little bit of administrivia, and then some things I hope you'll find interesting and useful pertaining to leading into new material in Project 3. Let's see. Okay. All righty. That clock says 4 o'clock, so I'll go ahead and get started. Today's topic is importing modules first using code other people or yourself have written. We'll get into Jupyter, or sometimes pronounced Jupyter, notebooks, which are an interesting tool for doing work, including Python coding, and which will be part of the basis of Project 3. Couple of administrative notes. Lab 9 will be released right after class. We will talk about it at the end of class because it'll make more sense then. As always, it'll be due Thursday night, right before midnight, 11:59:59. The lab is based on importing code and using it to run some programs. We'll go over it at the end of class. Homework 6 will also be released right after class. It's due Monday, the 27th. So you have a week before midnight. You have a busy week. You're full. You're already working on the project. Homework 6 is not too bad. We'll talk about it in a minute. It consists of 5 recursion problems. The hard part of each is identifying what the base case is and what the recursive case is. Once you identify the base case, it's really not hard. Other than comments, if you're taking more than about 20 lines of code to solve any of the 5 problems, you might be overthinking it. Project 2 is still due next Monday. The design is due tonight. I posted on Slack. If you're having a problem submitting for Project 2, the design, which is due tonight, should be submit CMSC 201, all caps, proj2 _ design, and then your file name. And then when you're ready to submit the actual project, it's just to proj2. So the design, which is a text file describing your design, gets submitted to proj2 design, and the actual program gets submitted to proj2. So that is the administrative portion of this. I do want to show you very quickly homework 6, which that is on GitHub. Should be. Let's double check this. Okay, if I didn't upload it, I'm going to have to do that right now. Hang on just a second. There's 5, 4. Oh, of course it's not there. I said I was going to upload it right after class. Hang on just a second. Okay. Emma. Okay. What I'm doing, I'll let you know when it's there. I'm trying to upload homework 6 right now. We'll come back to this in just a second. What I have also done is, if you haven't seen it yet, to GitHub, Blackboard, and the Slack channel, I have posted a set of test cases for your Project 2. And that set of test cases is things that your program should run on. And that's going to be similar to what I have the TAs. Jordan and Anna will be grading Project 2, And the way that works is that I give them a set of test cases very similar to what I posted, and they check to make sure your results are consistent with what you should see. So here is the test case file I posted for project 2. I give you 10 test cases. These are not exactly the same as you'll be graded on, but they're very similar. You won't, I gave you a test case where you should search for Will Wheaton. The actual thing you'll be graded on is just graded for another student whose name will match, and it will be found, and it will be unique. So this is something you should run your program, run against your program. What I have shown you is what keystrokes the user is expected to enter, and then what the expected output would look like. Now, I have not bothered in the expected output to show you the menus, right? You're going to display a menu, and the user's got to pick L for search by last name, and then you're going to display another menu asking for file. I haven't bothered showing you that. That's straightforward. But you should indeed match, even though Wheaton is spelled with funny caps. The next one is a search by a student ID. It's a student who will be found, and there's a unique match. There's not a problem. The third case is one where the last name is misspelled, and then the user corrects it and spells the last name right the second time. I tell you in this case that you should print out, of course, some sort of error message. The assignment describes it that says, no, that user was not enrolled in the class. And then, of course, when the user spells the name right and it's found, you should find that one. There's a case where the user will search for a name that's not going to be found at all because it's not there. We're not going to force the user to quit the program in this case. Case 5 is an easy one that appears everywhere, which is where the user just chooses to quit the program completely. You should, end your program and display a useful message. 6 is we're testing the spring semester list with a misspelled name. 7, the user entered an incorrect student ID. 8 is a student who was not in the class, and this time we do follow all the way through and quit the program. 9 is a case where there are 2 students with the last name of Cooper, and you should find that. You should work through and display. In the expected output, I tell you that I presume that the way you do your matching, you would display Sheldon Cooper as 1 and Mary Cooper as 2. So I presume that the user picks 2. If you happen to go in the reverse order, that's okay. It's not wrong if you put Mary Cooper 1 and Sheldon Cooper 2, then the user would select 1. That's fine if you do it that way. Similarly, for the 10th case, where we go through a couple of things with a misspelled name, both a misspelled name and 2 students with the same name. And now, going back to GitHub. I do want to talk it. We're going to talk about homework 6 at the end of class, since I do want to talk about that, but I'm having an issue saving it as a PDF. So let's get back to the topic of today. All right. The way we structure the class, the last week of lecture, so normally 2 weeks from now, we have the section of the class called Python Beyond 201. That module talks about things that you can get into in the future beyond what we've taught you. I've decided to move it forward because I think, given the disruption of the class from being online and the fact that you're not comp sci majors, I can make more use of it doing it this way. Now, when we get to this module in the major sections, the section we teach is structured pretty much based on the presumption that if you're in that class and you're a comp sci major, at some point in your career, you're going to be a professional software developer. Maybe as your primary job, maybe as your secondary job. So we structure the unit to talk about using the Django framework or the Flask framework or similar tools to professionally develop software using Python. Now, when I teach this unit this week, I'm going to presume, since you're not comp sci majors, your main interest is not in becoming a professional software developer. Your main interest is in developing software that will help you be the best engineer you can be, or the best mathematician, or a good chemist, or whatever. So I'm going to focus on tools that will let you use Python to solve problems that you're going to encounter in your career. So that's why we're going to break a little bit from the other 201 sections. We're going to cover some topics they're not going to cover, and vice versa. It gets back to an assumption, as I said, that I don't think you really want to be people who develop code for a living. If you do, by all means, great, go for it. This is not going to hurt you. So, Python. One of the big advantages of this language is that there's a ton of code out there that exists in the wild, that was written, that's open source, it's available for your use, and it has a ton of functions. So the math library, which you've actually imported to do one of the earlier, the first programming project, is a library of code that implements a lot of standard math functions that you'll need to know. This, in fact, is in part of Lab 9. You will import the math library and use some functions. You can see ceiling, combinatorics, copy sign, factorial, floor. There's actually functions that will automatically calculate the mean, median, and mode of a data set, and so forth. So the math library is out there, and it's useful in a lot of things. There's a library called NumPy, sometimes pronounced NumPy, which gives you built-in support for arrays. And from mathematics, with an array, you can find an inverse. You can solve systems of linear equations. You can run your linear algebra with it. You can do fast Fourier transforms in physics. Man, I wish I had something like that when I was a physics undergrad to do a Fourier transform. You can do lots of work with random numbers if you're into cryptography and things like that. A library I did a whole lot of work with a couple of years ago with the data science program is called Pandas. Pandas is short for panel data. It's a big data analysis and data science package. You can do a lot of things, and I'm going to give you an example of that in a minute and how it works. If you're into image manipulation, taking JPEGs or GIFs or what have you, PNGs, there's a library called Pillow that lets you do a lot of things with that. And if you're into graphics and plots, we're going to talk on Wednesday about ggplot and also turtle graphics. And then there's another one that's used to be the big one, is called matplotlib. ggplot seems to have overtaken it. Those are tools that will let you do a lot of graphing and plotting given a data space. And so we'll actually be doing some things with that with Project 3. I'll be giving you some data sets, and you'll be creating these funky visualizations and graphs and charts and all the things, and you'll be shocked at how little code it actually takes, because all these libraries are already built for Python, and they exist. Okay. Now, you can import any of these existing libraries into your Python program. Additionally, and you'll see this in Lab 9, you can also import into a Python program any code you've previously written yourself, or that your professor or classmate has written. If the package has already been installed, and we'll talk about that in a minute, you just use the import statement. In your program, you would say import math. Now, I put some comments in here that says in your program, import math imports the existing math library that we just talked about. You can now use any functions in that library. Or if you want to import the Hailstone program that we did from recursive programming in Lab 8 last week, it's just import Hailstone. Now, if you'll notice, the program was called hailstone.py, and we imported Hailstone. Python figures out that it needs to strip off the .py extension, and now you can use the flight function. Okay, let's get into some examples after I talk about basic formats. You can use the statement, as I've said, import math. That means you must include the module name in each function call. So to use the sine function, let's go into PyCharm. And let me share PyCharm. Sorry, I muted myself. I don't think I am sharing PyCharm, but let's fix that now. Okay, now let's get a new Python console. I'll keep the other one around. I need it. So the math library has already been installed on this computer. I don't need to install it. And that's generally the case with most Python 3 packages that you download. You've already got math installed. So it should not be an issue. To use math in our program, we just say import math. Great. Now, if I want to calculate now the trigonometric routines, sine, cosine, tangent, what have you, in the math package, if you look at the documentation, it tells you it calculates based on radians, not degrees. Okay. So what we can do is say print math dot sine of 0. Well, 0 degrees and 0 radians are the same thing. That's fine. The sine of 0 is 0.0. Obviously, it gives you a float number because all sine values have to be between 0 and 1, so integers aren't meaningful. Now, there is a very nice constant defined in the math routine. So I can say pi, my constant, is equal to math.pi. And now, what's the value of pi? It gives me pi to the number of digits of precision on this Mac, which happens to be 16. Depending on your computer, it may be more or less, but you should get around 16 digits of pi. Now I can use pi in my program and don't have to worry about typing it in initially or calculating it or doing anything else. So now, given that I'm using radians, if I want to say print math.sine of pi divided by 2, this tells me that the sine of pi over 2 radians, a 90-degree angle, is 1. So I have all of these math functions. Now, what that slide we were talking about was telling you is when I imported math using this import statement, okay, when I imported math using that statement, to use one of the functions in math, I had to explicitly state that this is coming out of the math library, the math module. So I said math.sine right there because I may have a sine function written someplace else that I wanted to use. So this tells Python I want to use sine out of the math library. That's all fine and dandy, but I may want to be lazy. Maybe I don't want to type math. Maybe I want to shorten it. I can say import math as M. And now what that does is that tells Python from now on, anytime I use M, that means the math library. And so now I can say print m.sine of pi over 2. Oh, look, I've saved 3 keystrokes. It works. I mean, in math, it's silly. You generally wouldn't do this import as, but you will see it with some of the other functions that I've talked about, like pandas or pillow or whatever, where people will generally abbreviate, and I'll actually do that in some examples in a little bit. Another thing I can do, if I don't want to go through the whole thing, is I can import, if I don't want to import the entire math library, I can import an individual function. When I do import math or import math as M, I now have every function available to me in the math library, which if you look at the documentation, there's a lot of them. I may not want it. Maybe I wrote my own median function. Maybe I don't want to use the math module's median function. I want to use my own. So I don't want to do that. I will just import from math, import sine. Now, I only have the sine function. I don't have the cosine function. Okay, but I can say print sine of pi over 2, and now I don't have to say math dot sine or m dot sine, because syntactically what I've done by doing this, by importing from, is I clarified for Python. Whenever I use sine, the sine function in my program, I mean the one from the math module. Okay, by doing it this way. Suppose I do want to use everything from the math library, but I'm still, I'm a programmer. I'm a little lazy. Let's be honest. I mean, I like computers doing things for me. What I can do is say from math, import star. Star is a wild card. It means match everything. From math, import star is the same as just import math. It means import every function that's out there. If it's there, I want to use it. Okay. So now I have everything, but again, I no longer have to print math.sine. I can just say print of pi over 2. I don't have to say from math. I can give it a number that's, I could just say cosine. Now, interestingly, if you remember your basic trigonometry, the cosine of pi over 2 is 0, right? The cosine of 90-degree angle is 0. Python gave us a non-zero quantity. Now, it's really, really, really small. It's 6 times 10 to the minus 17th. That's really darn close to 0. But what happens is, we've talked about this a little bit, floating point numbers can't always be exactly represented. It rounds off. And when it rounds off, what happened was it gave us this number that's not 0. So we have to watch that. That's just an interesting little side effect. The point of this statement was that I don't have to print math.cosine. I got the function that way. And then it zapped me by giving me a non-zero number for something we all learned the first time we took trigonometry is actually 0, and it gave me 0. So let's get back to the slides. And I'm going to take just a second while we're going back into presentation mode and see if I can actually upload my homework. Okay, the homework is now on GitHub, and let me see if I can get lab 9 there. Just a second so we can talk about them in a little bit. Now I can't quite get that now. We will do that in just a minute. Let's go on with this lecture. Okay, so we talked about importing math, in which case you include the module name. We talked about renaming, import math as M. You could use a simpler name. And we talked about importing only the functions we need, import just the sine function. And then you don't have to refer to the module name. You can just say x equals sine of 0, and this is valid. Or we can import all the functions using the wildcard characters star or asterisk. From math, import star. And now you can refer to all the math functions without referring to the module. If you're going to do this, if you're going to say from math, import star, and then use a function median, please make sure you don't have another median function with the same name, because now you've lost the ability to distinguish between the two of them. And Python has an interesting algorithm for deciding which is which. It's mostly going to pick the one from math, not the one that you wrote. Whether that's what you wanted or not, it tends not to care. Just a second. Hang on just a second. All right, back to the lesson. Now, I'm going to import, I'm going to install, import, and use the pandas module to read in and process a CSV file with a single statement and then show you an example of what I can do with that. So let's go back to PyChart. Now, I'm going to presume that pandas is not installed on this Mac. It actually is, so we'll see some error message, but this is exactly what you would do. I have a terminal here, a Linux terminal. What I'm going to do is type pip. Pip is Python install packages. It is one of the two ways we generally install new code from Python. The other is conda, C-O-N-D-A. So pip is more common than conda, but sometimes they might want you to use conda. Install pandas. And now what's going to happen is it goes out and it searches for the pandas package and it installs it. And if it, in that case, it just told me that it already was installed, so I was done. If you look at what's here now, this is from my installation of it a little bit earlier today. So I have pandas installed on this laptop now. You'll have to do that. Once I have done that, I can now use it. Okay, so let's remember our old file, spring 2020 .csv, spring 2022.csv, which let's see if I can figure out where I put this thing. No, we'll get back to that. Okay, let's see if I can remember. I'm going to import pandas. I'm going to call it PD. Now I can use pandas. Why? Because PD is shorter than pandas, and I'm lazy. And we're going to just a second. All right. Working on getting lab 9 up there so I can demonstrate, I can display it for you. Okay, now pandas has an interesting built-in function called read_CSV. Read_CSV does everything you did in your function where you read in the CSV file in a single statement. And so if I can recall the syntax correctly, I'm going to say df, df is short for data frame, equals pandas p.read_CSV, and the file name is spring_2022.csv. Hopefully this works. Nope, it didn't find spring2020.csv. Okay, where is spring2022.csv? Okay, I'm in my code. Okay, don't have it there. Hold on just a second while I find my spring 2022 file. This is what I get for not including this in all of my code. Yeah, I don't have it. Okay. All right. So I believe that the correct path name for this is on this Mac is users Alfred Arsenault downloads spring 2020 project 1-master /spring 2022.csv. Let's see if that works. Okay, how about that? Guessed right. That I now have read in that entire CSV file in one stroke with one statement this statement right here, I read in that entire CSV file, and look, Python, because of pandas, has filled in everything. And for those of you who remember Project 1, here are these obnoxious 9 rows I left in to tweak you. And Python, pandas has told me these are NaN. Now, NaN stands for not a number. In other words, we can't figure out what the bleep it is. It's just there. We can't fill it out. It's not a number. So it tells me I've got some data there, but it might not be useful. Okay. By the way, these 3 dots are the rest of the data that it can't display on the screen. It said you can't show me everything, but it all is there. I could expand and show you that the other columns are there. That columns 3 and 4 is not displayed because it was too wide, but everything is there. Now, so that whole thing you wrote a function for, one statement in pandas. Now, what about these 9 rows? I mean, think about, for a number of you, how hard it was, how many statements you had to do to get rid of them, and what kind of a pain it was. Well, pandas has some nice little code already. It has a function called drop NA, df.drop.na. What drop NA does is it says any row that has these not a number things in it that looks useful, it throws them away. Now, I ask you right now, it's 35 rows, 8 columns. Whoa, it's now 26 rows and 8 columns. So with one statement, I got rid of those obnoxious rows in the CVS file, and now I'm back to actual useful Python, useful data that I can do with Python. So that's an example of the code that's out there that you can use. You can simply import pandas. It lets you read in a CSV file. I imported pandas. I decided to be lazy and call it PD instead of pandas. I read in the file using the single statement read CSV, and I just dropped those pain in the neck rows of commas with the drop NA statement in pandas, and I'm done. I now have a useful CSV file that I can do whatever I want in Python.
Question.
Certainly, go ahead.
Before you started this, the file, the package.
Yep.
How do you do that again?
Sure. Typically, let me pick another one that I don't have. What else did I use as examples of packages? Hang on just a second. I don't have matplotlib. So I go to a terminal, and I'm going to say pip install matplotlib. I give it that command. That's the command. And from there, Python will tell you, hey, I'm going out to get it. You see all these statements and everything, and now it's done. So that's it. Okay. Now, so you usually, I did say you usually use pip. PIP stands for Python Installer for Packages. It's the most common one. There is another one called Conda. And let's see if I get, it works just the same. Let's say if I can see if I can actually get Conda to install Pillow, which is the package that does graphical interface. It lets me edit images. Okay. It's trying. And we're going to find out if it works or not. If it goes too long, I'm going, here we go. Conda's working now. It's working through it. Actually, I think Pillow, because it works with graphics, is a lot more intensive than Pandas. So I think, or Matplotlib. So I think this is just a bigger file. Following packages be updated. Oh, it wants to update Conda. Okay, which is cool. Again, Python does a lot of this automatically. This is just updating the file that it uses to do it. And now it's good. I'm done. I now have what I now have is the Pillow package available. And so now I can come back and I'll do this in a console. I can now import matplotlib because I installed it. I can import pillow because I've now whoops, it doesn't finish. Okay, I'll double check that one. That was the one that I had Conda install. Why did it not do that? But at any rate, I generally use pip, as I've said. Conda will work, and if you want to use Conda, let me know, because as is always with live demonstrations, that one failed. So I'll figure out exactly why Conda, but I would use pip. Pip, add a command line in a terminal, whether it's a terminal in Mac or a command line processor in Windows, command window, or just the Linux command line on GL. It's just pip, PIP space install, and then the package you want. Okay, so let's get back to importing your own code. Here, I'm going to do a couple of things. First, I'm going to write a program called dates.py. It's going to take any date represented as a string, month, day, year. It's going to have a function called convertDate, and it's going to change that string of month, day, year into the Julian day, that is the ordinal number of the day in the year. So January 1st is going to be 1. February 1st is going to be 32, and in a leap year like 2020, December 31st is going to be 366. The Julian date is just the date, the ordinal number of where the day occurs in the year. So I'm going to take in a string that has I'm going to take a string that has the date, and I'm going to convert it. So first, what we're going to do, we're going to go to PyCharm, and we're going to write that function, that program, which consists of the function and name program. This will be put on GitHub later. I have not yet had a chance to get that there. This is called dates.py. The name dates.py is significant. Dates.py has a function called convertDate, and it has a main program, which is just a skeleton that tests convertDate. So what I did is I said, let's take July 4th, 2020. July 4th, 2020 is month 07, day 04. Let's undo that. Month 07, day 04, 2020. That's July 4th, 2020. It's a string. I'm going to come up. The main program, as you can see, all it does is it tests the function for me. The key to this program is the function. So now, in the function, it takes a string. I've been a good programmer. I actually had a little energy. So I wrote my comments. I said, this function takes a string representing a day of the year. The date format is month, month, day, day, year, 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 4-digit year. That's what the string's going to look like. I'm going to return an integer, which is the Julian date of the year. That is the ordinal number of where the day is in the year. Now, in order to do that, the first thing I need to do is get the month, the day, and the year in meaningful integers. So here's what I do. I know the first two entries in the string represent the month. To get the first two entries in the string, I slice. I start at the beginning and I stop. I don't want to. So this S square bracket :2, this gives me S0 and S1, month, month. So in the thing that's being passed in, this slice S square bracket :2, this gives me the first two entries in the string. This is going to give me that 07 and 04. I mean, that 0 and that 7. This, in other words, right here, is going to give me the characters, the substring 07, and then I'm going to convert it to an integer. Okay, I'm going to convert that to an integer, and I'll show you in a console how that would work. So we're going to say S equals the string 07042020. Now I'm going to say month. First, I'm not going to convert it. I'm just going to leave it as a string. If I do that, you can see month is now the string 07, but I really need it as an integer. So I'm going to say now month equals integer of month. And now you can see that month has the value 7. So July, the 7th month. So what this statement does is it gives me the first two letters, first two characters of the string, and it converts them into the integer 7, which represents the month. Now, the next two in the string, remember, it's month, month, day, day, and then four digits for the year. So I'm going to take these two these two things out of the string and convert them into the day. I do that exactly the same way. This is S sub 0. This is S sub 1. This is S sub 2. And this is S sub 3. So how do I slice the string? How do I slice the string in such a way that I only get S2 and S3? Well, I do it this way. I take S, I start at 2, colon, and I stop before 4. I do not want 4 in my substring, so I do it this way. So this S2 to 3 gives me 2 and 3 in the string. That's going to be a string. I convert it to an integer, and it's going to give me a day. It's going to give me the integer for the day. So just to prove that, I'm going to say day equals int of S square bracket 2 to 4. And now I can see the day is 4. So now I have the month is 7, July. The day is 4, July 4th. And now for the year, that's just the last 4. So this is 0, this is 1, this is 2, this is 3. I want to start at 4 and go to the end. So S of 4 to the end is going to be the year, and I convert it to the integer. So let's show that that works. Int of S from 4 to the end. And now I can see that I have the integer 7, the number for the month, the integer 4 for the day, and the integer 2020 for the year. Now I'm going to convert, and I'm going to be the first to acknowledge that this is kind of ugly code, but it works. It's quick and dirty. It works for this year. It works for a leap year. J underscore day, Julian date, is going to be my variable that has the Julian date that I'm going to return. I'm going to start by saying, if this is easy, if every month had 30 days, then I could always calculate the Julian date by saying, what month number is it minus 1 times 30 plus day, and that would always give me the correct day, right? In January, month minus 1 is 0, so that throws that away. The Julian date is just the day, right? The 15th day of the year is January 15th. We're done. Now, the problem is that not all months have 30 days. January has 31. So if I just stuck with this formula, I'd get a wrong answer. So I have to correct. Now, like I said, my correction is ugly, but it works. It's just quick and dirty. It explains. If I am in February or April, you can go back and test this yourself. To correct the Julian day, I have to add 1 to what I calculated up here. Else if I'm in June or July, I have to add 2. If I'm in August, I have to add 3. If I'm in September or October, 4, and November, December, I have to have 5. And just to have it a complete statement, and else down here, I don't add anything. I add 0 if I'm actually in January or March. Now, that works because This is a leap year. February has 29 days, so January plus February combined have 60. So this actually does work. As I said, it's ugly. It gives me the answer I need. I'm just going to return this number, and that is the Julian date. So to show the whole program works, I test it with one value, July the 4th. I come down here. I run it, and July 4th is the 186th day of the year in a leap year. In a non-leap year, I'd have to write the code, and it would be the 185th. All right, so this is kind of a silly program. Pardon me, we had a dog climbing on my lap. This is kind of a silly program, but it works, and it's called dates.py. Now, what if I don't want to have to ever write that code again? I have lots of programs that need to calculate the Julian date, the number of day in the year of whatever date you give me. You give me month, day, year, I'll give you the day of the year, the Julian date. What can I do to avoid rewriting this code? Well, obviously, I could always copy and paste it, but I don't want to copy and paste it. I mean, you've been programming for almost a whole semester now. You should be able to do this. The thing is, I just import this program. I can import this dates.py into another program and use it. And so I've got two different examples of doing the same thing on the slide, but I'm actually going to try to do it. Well, actually, I'm not going to do it in real time because that would fail. I'm going to use the code I wrote before this. I'm going to, the simplest way, I'm going to import dates. Now, notice this program is called dates.py. This does not say import dates.py. It just says import dates. The reason is Python presumes all of your modules that you wrote and that you are going to import will end in .py. In fact, they have to. There's some exceptions, but we're not going to cover the exceptions. For now, for this course, when you write a program and then you import it into another program, the program you're importing must end in .py. So dates.py, you import it by just saying import dates. You leave off the .py. Now, the program just says if name is main, print dates.convertDate 0704. So here we have a separate program, and just to show you, I'm going to start over with a brand new Python console. I'm not going to keep anything from before. I'm just going to copy this code. And it works. It gives me the same value I had before. July 4th in a leap year is the 186th day of the year. If I wanted to test this again, let's change this to August 5th. August 5th is 32 days after July 4th, so 186 plus 32 is 218. I should be able to get this to give me the same value. What did I do? Here I go with live demos again. Okay. And indeed, I got 218. Let me undo my typing. There we go. So I didn't ruin everything. Okay, so it works for any date you want. It's a string in month, day, year format. Now, I said there's two ways to do it. I showed you the easy way, just import dates. When I imported dates, I had to go say, use the convert date function in dates. I could syntactically, this is on the slide, alternatively, say from dates, I want to import star. Here, I'm using that wildcard, and now I do not have to say dates.convertDate. I just say print convert date, July 4th, 2020. Do this without fouling it up. And indeed, it gives me the straight thing. So this is how, and you'll do this in Lab 9, this is how you import code that you or somebody you know has already written that's not publicly out there. But you don't have to write the function again once you've done it correctly. Okay? Now, one thing I want to point out, because it might, probably not, but we'll give it a shot, explain something. When I imported dates.py, I could use this function. Okay? I could use this function that's highlighted when I imported it. That's cool. If there were more functions, I could use those functions too after I imported them. What about down here? The if name equals main. That can never be used when this module, when this program is imported. When I import a program, I can never use what's down here in the main program of what I imported. The stuff that's highlighted can never be used when I import this. That's the ultimate meaning of this line that says if name equals main. This code can only be run if this program is executing as the main program, which is not the case if this is imported. So this code after this statement can only be run if this code is running as its own program. It is not imported. That's the actual meaning of that statement, which it took months to get there, but that's what it is. So that was what I wanted to illustrate. And let me go back to the slide now. And that was my point about importing your own code. You write a program called dates.py. We showed how to do that. It includes a function called convertDate. Then we'll write a separate program that imports dates and calls that function. And I have the two different examples on the left side and the right side of how to do it. Depends on how you want to write it. By the way, nothing is more correct than the other. Each of these ways of doing the import are equally correct. It's all fine. There's no pluses, minuses on the points if you do it that way. But that's it. The beauty of this is once you've written that convertDate program, you can import it and reuse it. And now all of a sudden, your main program gets really short and sweet. It's really nice. I mean, that's really all that it is. So it's a very nice feature of Python that you can actually write your own code, stick it out there in a file as long as the file ends in .py, and then you can invoke it, you can use it, you can rerun it in different programs. It's trivial and easy. You're set. The rules for importing your own code is that the name of the module must end in .py. Again, that had to end dates.py, hail.py. In the lab that you'll be doing this week, Fibonacci.py. You must have something that ends in .py so that the import statement can recognize it and find it. Now, it also has to be findable in the Python path. As you saw with my error when I first tried to read in the spring 2022 file from the pandas module, that file was not in the path, it was not in directory, couldn't be found. So I couldn't use it. The easiest thing to do is you put the file you're going to import in the same directory. If you can't put it in the same directory, put it in a directory Python always searches for programs, or just include the entire path to the file in the import statement. Okay. In terms of where Python searches, we're going to import a module called system or sys. Okay. Now there's a variable sys.path. What this will do when you run it on your computer is it will tell you where Python will search for any file you mention or any module you mention. Now on my Mac, it will look in applications PyCharm. It will look in ce.app contents helpers PyDev. It will look in Python applications PyCharm CE contents helpers third party thrift. It will keep looking at all of these things, go all the way out. This will tell you where it looks. Okay, and you can see that since I've added pip, it will search in pip, the pip directory for Python files, and it will look in. This happens to be the current directory. I'm actually still working in a directory I created back in January for the code that I upload to you students, which will include this stuff after we're done. So basically, you have to put the module someplace it can be found. As long as it can be found, same directory, you give it the full path, or it's in one of these directories, you're good to go. Okay. Let's make sure I'm where I think I am in the lecture. I am. That being done, I have now uploaded the lab file, and I want to talk about it. Okay. Labs are in the homeworks, etc. directory. This should be there. Yes. Lab 9 is now there. Again, this is due. I'll get you the submission instructions. It's not included. I'll get them out to you. It should be Lab 9 and should be all caps. LAB 9, all caps should be the way to do it. What you're going to do in Lab 9 is getting practice importing code and calling it. You're going to work in a directory called Lab 9. Part 1 is going to be importing the math library. So you are going to import math, which we talked about and we showed a little bit in your program. I give you a link to where the documentation is for the math library if you're not sure what the functions are called or what parameters are needed, what arguments, whatever. So I'll give you that pointer. You can go look it up. You import math, and then I want you to use the math factorial function in a loop. Calculate and print the factorials of the integers 1 through 10. Just run this for loop and print it out. Then use the sine function that we talked about and showed you. Again, this is in radians, not in degrees. Use math.pi to get a value as we showed here. Just a second. Oh, apologies for the obnoxious phone. Any rate, use math.sine and math.pi to print the sines, trigonometric values of pi over 2, pi, 3 pi over 2, and 2 pi. You should know what those are: 0, 1, 0, -1, and 0 again. And you may get something times 10 to the minus 17th. If you do, it's okay. Part 2 of the lab, I've written a couple of programs which include functions. I have them on gl.umbc.edu. Copy the 2 functions. Let's see if I can get it there. Okay. Let me real quick share my terminal. This is my terminal on my Mac. I am logged into gl.umbc.edu. I am in my pub directory /AFS umbc.edu users AR arsenal pub. This time I actually got it correct. And there are 2 files you are going to copy out of this directory fib.py, which calculates Fibonacci numbers recursively, and hail.py, which is a variant of the Hailstone project from last lab, which calculates how a hailstone falls on this strange planet with this strange gravitational rule. So we will look and see fib.py just is a recursive definition of how to calculate a Fibonacci number. It has a very simple main program, which I used to make sure that it actually worked. Hail.py is a recursive implementation of the how a hailstone falls on this planet that we talked about last time. The function is called flight. Again, I wrote a very simple main program to test it, to demonstrate. You can take a look and see how it works. Okay, so what Lab 9 Part 2 does, you're going to copy that hail function. You're going to copy that Fibonacci function, or the fib.py and hail.py. You should be able to do that. If you can, if there's permissions issue, let me know. I'll fix it. I think I got it this time. You can ignore the skeleton main programs because you can't use them. If you want to run the programs, feel free to show that they actually work. What you're going to do is write your own program that imports these files and uses the flight function and the Fibonacci function to do some calculations. Okay, so when you write your file in Lab 9, the first two things you do is you import hail and you import fib. Remember, hail.py, fib.py, you don't add the .py instructions, the .py extension, you just import them by hail and fib. Now your functions, their functions are available, flight and Fibonacci are available for use in your program. So your main program for part 2 of Lab 9 is fairly straightforward. You're going to write a main program that calls these two functions to solve a problem. Okay. You can do hail.flight. We've talked about this. You're going to say in your main program, if name is main, for I in range 10, you're going to calculate the first 10 Fibonacci numbers by calling fib.fibonacci. Then you're going to call hail.flight with the number as the Fibonacci number as its argument. And then you're going to print out the result. So basically, your result of this part 2 is going to be 10 statements that says it takes this many steps to fall to the ground from a height of whatever your Fibonacci was. So your first number should be 1. It takes 0 steps to fall from 1. The second number is also 1, the second Fibonacci number. It should take 0 steps to fall from 1. The third Fibonacci number is 2. It should take you 1 step to fall from 2, and so on. So that's what you're doing in Lab 9. As you can see, pretty straightforward. It just gives you a little bit of practice importing. First, in part 1, you're importing a standard library, the math library, and using its functions. And second part, you're importing some custom written programs that do, let's be honest, silly things. But it works to solve some problems. You're really only going to be writing, half a dozen-ish, maybe 10-ish lines of code for each of these. I just want you to get practice importing code and using it. So that's Lab 9. Okay, now homework 6, which is not due till next Monday. Let me go back to that before I get to Jupyter Notebooks, Jupyter. Homework 6 is just recursion. Now, as I said, come on, be quick, GitHub. More live demo fails. If homework 6 did not load properly, I will reload it. And we can talk about it Wednesday, as I said. Homework 6 is just 5 recursion problems. I'm checking to see if it fails on a different computer. And if it fails, as I said, I will just reload it. And we'll talk about it Wednesday. I'll reload it as soon as this class is done. I've wasted enough time. We'll talk about it on Wednesday. The last thing I want to talk about will be the focus of Project 3, which is the Jupyter or Jupyter notebook. Now, Jupyter is a phrase that comes from the language Julia. Ju is from the language Julia. Py from Python, and R from the language R. So this is from the languages Julia, Python, and R. It was originally called the IPython notebook, and it's a format for producing documents that are very useful in handing in some complex analysis. Okay. So what we'll do is we'll go to, it's hosted on Jupyter or Jupyter.org. There are a number of different products there. The one we care about is the Jupyter Notebook. In this case, we'll just simply try it in our browser. To be familiar with it, we'll do some more of this on Wednesday, because Wednesday's lecture is going to be using this to do some graphics. We'll import some of the graphics libraries and do some graphic calculation. The one we care about is the classic notebook, because that's the one that uses Python. We don't want to deal with Julia or R or anything else right now. When you install it, it will usually take a while, but it will load a tutorial, and then it will let you create a new notebook. And this is what it will look like at start. Yeah. Live demo is nothing better. Let's get this one. Okay. All right. Hang on a second while that is happening. I'm going to destroy that version of homework 6. Okay. I have deleted the corrupted version of homework 6. Now let's make sure I've got a clean version of homework 6. Okay, let's upload that. Okay. Sixth on PDF. Wow. That's a big one. Okay. Let's see if this works. There we go. How about that? Okay, Jupyter. Okay, this is what you will get when you go to that website and start with the Jupyter Notebook. So we will go to File and create a new Python 3 notebook, which is the different. It will look like this. This is a blank cell. You type in cells. You can include Python code. It can be Python code that you run. It can be text. It uses, for text, it uses something called Markdown, the Markdown format. And let's decide that this cell should be a Markdown cell, which is just straight text. It's going to be a heading. So I want a heading that's of type 1. This is going to be the newspaper heading. Now I want to install a new cell below it, and I will actually put Python code def fact of n. If n less than 3, return 1, else return n times fact of n minus 1. And now a simple code, simple main program to test it, factorial of 5. And now what we can see is that when we run this, we get the answer. Hang on a second. Pardon me. That's why that was the wrong answer. It should be with n is less than 2. I'm in the Fibonacci world with n less than 3. Let's try this again. That fixes it. So now we have Python code in the middle of our report. Now let's put a subheading here. This is a report including Python code embedded in it. Okay. And now we will make that a markdown cell. And you see that it's a subheading. It's a heading 2. It's a little smaller than that. Let's put another cell below it, which will have Python code. And this is where we'll import math. And we'll say print the sine of pi over 2 radians is, comma, math.sine of math.pi divided by 2. And now we will run that. And so this is a tool where you can do your work and run the code and update this. The reason this is relevant for a lot of work, the reason these are used so often in academic research, and they're used in industry, a number of my people I do consulting for use them as a regular basis, is because you can include the code, and every time you get a new data set, you simply rerun the code, and you can get whole new results. So you can actually have this read from a specific file. Of course, you have to have the file in the right directory. And since we only have 3 minutes left, I'm going to go to what the homework is today, and we'll show how that works in detail on Wednesday when we do the graphics. The bottom line is, for project 3, I'm going to have you build one of these notebooks with some graphic programming, showing various plots and charts with some data sets that I'm going to give you that you're going to get offline. And it'll be an example of using Python programming to solve a problem that you might occur in your career. Hopefully, for most of you, that will be useful at some point. Now, what I'm going to do is go back to homework 6. This worked on the Windows box I just tested it on. This should be the current version of homework 6. Yay, it works. Okay, standard introduction. Yes, you have to have all the comments, the file name comments, the function comments, what have you. Part 1. You are going to write a recursive program that draws an isosceles right triangle on the screen. You're going to prompt the user for the height. Remember, isosceles right triangle, the 2 sides that aren't the hypotenuse are the same length, so you only need the user to enter the height. The height and the base are the same. And the user's going to tell you what symbol to draw the right triangle with, hashes, sharps or pound signs, or whatever you call those, dots, dollar signs, whatever. This is a fairly simple problem. Think about the base case. Now, we're telling you, you don't have to validate input. The input will be an integer, and it will be positive, be greater than 0. You don't have to worry about the user saying, I want 0 or I want negative. That's fine. The user's going to enter a positive integer. So think about what the base case would be. What would happen? What would the triangle look like if the user said, I want it 1 high and 1 wide? What would the triangle look like if the user said, I want it 2 high and 2 wide? One of those is kind of a base case, and then recursion, you can think about just, well, this is one more than the last one, right? Okay, so it's fairly straightforward. You're going to write this recursive function. Your main program to exercise that and draw the triangle is going to be pretty straightforward. 2, find the factors of a positive integer. Again, you have to do it recursively. The user will enter a positive integer. Again, don't have to validate. It's going to be really a positive integer, and you're going to factor it. Basically, what you're going to do is have a quick recursion that tests to see whether each number can be a factor of this integer, and you're going to go all the way through, and you have to print them out, smallest to largest. Now, saying you have to print out the factors, largest, the smallest to largest, should pretty much tell you where the base case is going to be. And if you think about the base case, the recursion is pretty straightforward. Problem 3, reverse the characters in a string. We've got an arbitrary string. The user's going to type it in. We're going to print it out, and we're going to print out a message that this is what it is spelling backwards. You're going to write a recursive function. It's going to take one parameter, the string, which is not empty. Empty strings are not an issue. We're not going to deal with that. It's going to return the string backward. The main program is going to do the input and the output. The one thing you have to do, and I decided I'd warn you, remind you, we talked last week. Python, strings are immutable variables. You cannot directly change individual letters in strings. It will not work. Python will not let you swap individual letters in strings. So what you're going to have to do is split the string. When you split the string, you get a mutable type. When you have a mutable type, then you can switch letters around. You can switch the first and the last. You can switch the second and the next to last. You can switch the third and you can do that, okay? So there's a little bit of a trick. You're actually going to have to do a split, excuse me, and then you're going to have to do a join when you're done. 4 is you're zipping together lists, 2 elements, putting them together, one and the other. We talked about this in dictionaries. There is a function already defined in Python to do it. You're going to write it yourself because why not? It's easy to do recursively. And the last one is you're going to do multiplication without multiplying A times B. If I let you do it iteratively, you just write a loop that says, well, to do 3 times 4, just add 3 together 4 times. 3 plus 3 plus 3 plus 3 is 3 times 4, and we're done. Cool. But you have to do it recursively. Again, fairly straightforward. Think about the base case. How you do that, once you've got the base case, the recursive case follows straightforward. Okay. Now, the warning here is that the user will enter an integer, but the user may enter a negative integer. So you're going to have to deal with an input of negative. Because when you think about your recursive base case, you go, well, if you multiply anything times 1, you just return yourself and you're done. But what if the user entered -1? How are you going to do that? It's a little bit of a trick, but once you understand how to do that, the bottom line on homework 5 is, I know you're working on the project. I know I'm giving you the lab. I know it's a lot of work. I understand that. But what I'm telling you about these 5 problems is they're actually fairly easy. Once you lay out the base case and the recursive case, not counting comments, and you need to have comments, but not counting comments, if you go more than about 20, 25, 30 lines of code on each of these 5, you're overthinking it. I mean, my solutions were probably all in the length of maybe 20 lines of code, a few fewer, a few more. They're just not that hard. Sit down, think about them, come up with the base, come up with a recursive, and you're done. And I have now kept you longer than 5:15. So do you have any questions, or do I let you go and we'll join again on Wednesday? Going once. Going twice. All right. Thank you all for your attention. I know we're working hard. I appreciate it. We'll see you Wednesday.